The picture above me is flooding in Cleveland a few weeks ago during the intense rains we got on Labor Day, nearly 4 inches in some places. In this lecture, I'll be talking about natural and human factors that affect flooding. In most cases, the single most important ingredient for a flood is precipitation. Large amounts of rain falling in a short space of time or continuing over days set the stage for a flood. In the US, we get localized floods from intense rain and thunderstorms, and more widespread flooding from tropical storms and hurricanes. In snowy areas, we can also get floods from snowmelt, ice jams, and when spring rains help rapidly melt the snowpack. As shown above me, the Red River of the North in Minnesota and North Dakota frequently experiences floods associated with snowmelt and ice jams. The land there is very flat and floodwaters can spread for miles. A second factor that affects flooding is the type of soils. When all of the pore spaces in a soil are already full of water, rainfall cannot infiltrate, so it will run off over land and contribute to flooding. And some soils have small and poorly connected pores which limit infiltration. These clay-rich soils also result in more flood-prone areas. A special type of flood is the flash flood. These floods are typical of smaller watersheds where intense rainfall can quickly arrive in the stream channel. When all of the water reaches the stream at basically the same time, you get a very rapid rise in water levels associated with flash floods. Flash floods occur in urban areas and deserts as a result of sudden storms and impermeable ground cover. Flash floods can also be deadly in mountain canyons, where signs warn visitors not to try to outrun a flood, but instead climb to safety. In downstream areas, it takes time for water to reach the stream and also time for water to move through the stream network. Plus, it may not rain in all parts of a large watershed in the same time, or even at all. This means that in larger rivers, floods are slower to rise, but last much longer. They last longer because water is traveling from multiple different areas to the flood zone, and that travel takes different amounts of time. On very large rivers, flooding can last for weeks or months, like in the image above of the Mississippi River. In the image on the left, you can see how a rainstorm in the headwaters produces different types of floods at different positions in the river network. Now let's turn to how humans can affect flood severity. Plant roots hold on to soil and take up water. When they are removed, floods can get worse. Often vegetation removal is accompanied by soil compaction, which favors rapid overland flow over slower groundwater movement. Plus, without roots holding the soil together, erosion becomes more of a problem. Eroded sediment can fill channels, making it easier for water to spill onto the floodplain. Deforestation and vegetation removal has been linked to increased flooding in many parts of the world. In urban areas, land clearing, even before construction begins, can contribute to worsening flooding in local streams. As we already talked about, urbanization creates a lot of impermeable or impervious surfaces, including pavements and rooftops. These stop infiltration and promote stormwater runoff. Then we install storm sewers to quickly drain our roofs, streets, and parking lots into streams. The net result is more frequent floods, higher flood crests, and shorter lag times. Another way that humans affect flooding is through wetland loss or drainage. Wetlands are areas that naturally soak up excess water and temporarily store it. They have been called natural sponges. But humans often have other ideas for wetland areas and have drained many of them for agricultural land, timber harvest, or urban development. When we lose our natural sponges, more water makes it quickly to streams and rivers, and flooding gets worse. Ohio is typical of wetland loss in the Midwestern US. 90% of Ohio's wetlands were drained between the 1780s and today. Most of the wetlands were drained for timber harvest, followed by agriculture. Huge wetlands were lost in the northwestern portion of the state, as shown in the map on the table, but wetlands were also lost in northeastern Ohio. Today, wetland loss is often the result of urban development. But fortunately, we are increasingly recognizing the importance of wetlands for moderating flooding and improving water quality. So wetland restoration and construction are also happening. As I mentioned earlier, climate change can intensify flooding. We'll talk more about this towards the end of the semester, but a warmer atmosphere can hold more water and makes extreme rain events more likely. That leads to increased risk of flooding in many areas. This map shows the increase in runoff from the wettest 5% of days, comparing the years 1990 through 2010 to projected climate in 2050. 42 out of the 48 states shown on the map will have more heavy runoff, which can increase flooding. Let's talk about some of the things that humans can do to try to mitigate or reduce the impacts of flooding. Let's start with dams. Dams are walls that hold back water in a stream. They can be built for a variety of purposes, one of which is flood control. One key feature that makes a flood control dam different from other types of dams is that the water height in the reservoir upstream of the dam can be adjusted. Water can be let out of the reservoir if a flood is likely to occur, for example, before snowmelt in the spring. Then the reservoir has space to hold back incoming floodwaters and protect downstream areas. The image above shows a reservoir in Oregon that was built for flood control. Notice how the trees stop some height above the water, and then you have an area of bare soil and grass. That bare soil and grass is the area that could be filled for flood control by this dam. Of course, building a reservoir requires permanently flooding some upstream areas. In some cases, communities have had to be relocated to build reservoirs to protect and serve downstream areas. Dams built for flood control also serve other purposes, like hydroelectric power generation, recreation, and water supply. We will talk more about dams in relation to renewable energy sources in a few weeks. Levees are another strategy that people have used to try to control floods. Levees are walls built along rivers to protect property on the floodplain. They confine floodwaters to the channel and keep the floodplain from flooding. This can be very valuable if cities or other critical infrastructure were built in the floodplain. But levees also raise the flood height in the upstream non-levied areas by creating kind of a nozzle in the levied area that backs water up upstream. And levees can encourage further development on the floodplain, even though they don't completely eliminate flood risk. You see, levees are only built to a certain height. So if a bigger flood occurs than they were designed for, they will overtop. They also have to be well maintained to prevent failure. In the right-hand image, you can see some rural or exurban driveways coming off the road just inside the levee. This is potentially an example of development that would not have occurred without the levee, excluding floodwaters from the floodplain. As we've seen, urbanization tends to increase flooding. Since the 1970s, we've come up with engineering strategies to reduce some of the impacts of urban development on streams. One major method used is retention basins, or stormwater ponds, which provide short-term storage for stormwater runoff, which is then released into the stream over several days. Such basins and ponds reduce peak flows and increase lag times. Another set of strategies we use to manage stormwater is collectively called green infrastructure. Green infrastructure includes things like rain gardens, shown on the right, and green roofs that promote infiltration of stormwater into the soil and then encourage plant water use. Green infrastructure decreases peak flows, increases lag times, and decreases overall stormwater volumes. Stormwater management strategies like these can also improve water quality entering urban streams. Finally, there is a whole set of things we can do to influence the risks associated with flooding. On this slide, I'm showing 3 things that don't change how much water is in a flood, but they do help keep us safer. Elevating buildings in floodplains and other floodproofing measures reduces the damage associated with flooding. Public education campaigns like Turn Around, Don't Drown can help people learn how to stay safe in a flood. Floodplain mapping shows us spatially the areas that would be inundated in 1% or 100-year and 0.2% 500-year floods. Zoning that discourages development and protects critical infrastructure from going in these areas can greatly decrease the amount of flood damage and risk to life that we experience during a flood.